Many of you will have studied box and whisker plots at GCSE, so a lot of this will be revision, but taking the topic a little bit further. For a box and whisker diagram, you need to have an axis, usually drawn horizontally, with a linear scale. So notice the numbers 0, 10, 20, 30, 40 are evenly spaced on the axis, and the axis must be labelled in context. The box is drawn from the lower quartile to the upper quartile, and there's a line in the box indicating where the median is. The whiskers are drawn to the highest value and to the lowest value. If there's an outlier, that's shown separately with a little cross or a little asterisk, and then the whisker is drawn to the next number, the first one that's not an outlier. If that's not known, you use the boundary for outliers. Here's an example with 30 measurements of blood glucose. The numbers have to be written in order first. That's already been done. The median splits the data into two sets. So in this case, it splits the data into two sets with 15 in each set. The median will be 3.8. Each set has 15 numbers in. So the middle number will be the 8th number. So here, 1, 2, 3, 4, 5, 6, 7, 8. 3.2 is the middle number. That's the lower quartile. And the upper quartile splits the other 15 numbers into two equal parts. So we have the lower quartile, the upper quartile, and the median. The interquartile range is upper quartile minus lower quartile, which is 0.8. To determine whether there are any outliers, you want to see whether there are any values which are more than 1.5 times the interquartile range above the upper quartile, or more than 1.5 times the interquartile range below the lower quartile. Notice it's measured from the quartile, from the end of the box, not from the median. The number 1.5 would be given to you in exam. It's usually 1.5, but you will be told what number to use. Working it out, looking at the bottom, outliers would be lower than lower quartile minus 1.5 times the interquartile range. Any numbers lower than 2. There is an outlier. 1.7 is lower than 2. The upper ones, 4 plus 1.5 times the interquartile range, 5.2. There weren't any values that were higher than 5.2. So drawing the box and whisker diagram, we have the lower quartile, the upper quartile. The upper whisker goes to the highest value. The lower whisker goes to the lowest value that wasn't an outlier. For the males, we aren't given the individual values. We just have the highest value, the lowest value, and the quartiles. So for the box and whisker diagram for the males, we can draw the box. We can draw the, see whether there's an outlier, which there is, using the same rule. We find that 1.4 is an outlier, but we don't know the individual values. So this time, the end of the whisker was plotted at the outlier boundary, which was, in this case, 1.95. Box plots are useful for comparing two data sets. When you're comparing two data sets, you compare a measure of location. If you're using a box and whisker diagram, you'll compare medians, and a measure of spread. If you're using a box and whisker diagram, you'll use interquartile range, or possibly range. So for this one, making the comparison, the median is slightly lower for females, so we interpret that by saying on average the females had slightly lower blood glucose, and the interquartile range and the range for blood glucose was smaller for females, and so we can say that the values for females were less varied than for males. Here are box and whisker diagrams comparing the masses of female and male turtles. So again, if you're comparing and contrasting the masses, you compare the medians and comment on the average, and you compare the interquartile range and comment on how varied the masses are. One turtle had a mass of 330 grams. Is it likely to be male or female? It's likely to be female. Very few of the males had a mass this low. What's the size of the largest female turtle? There was an outlier. She weighed 500 grams.